Okay, so in this segment of the video, this is called neutrons. So we're going to talk about neutrons real quick. Neutrons have a neutral charge. Okay, there's no charge, none at all, no positive, no negative, no nothing. It's just like it's just there because it just wants to be there. I don't know. It's bored. It has no dog in the fight, if you will. Okay, it's just there. It's just no charge. It doesn't mess with anybody. It's just neutral. Think about it. When you have two of your best friends fighting, do you want to pick one side or the other, the good side or the negative side? Or do you just want to be neutral and be there to listen to both of your friends? Okay. If you're the kid or you're the kind of person that when you have two people in your life that are fighting amongst each other, maybe it's your parents, okay? Maybe you don't want to take sides. Maybe you don't want to be with the positive or the negative, okay? You just want to be neutral. You just want to be there for your friends and support them or your parents or your family, okay? That's all neutrons do. They're just there for support. The reason they're there is to keep those protons from floating away in that nucleus. Otherwise, the protons would just be everywhere, and then atoms wouldn't even exist, and oh my gosh, it'd just be a big nightmare. So you need those neutrons, those neutral things, to kind of just listen to you and just kind of keep you together, all right? I mean, doesn't that happen in life? Aren't people sometimes neutral in an argument because they don't really want to get into the argument, therefore they just want to support the person that's doing the arguing, all right? Neutrons. They are located inside the nucleus. And who are they hanging out with in that nucleus? The protons. Remember, if you're going to be neutral, would you rather want to hang out with the positive guy or the negative guy? I would want to hang out with the positive guy, but that's me. It has a neutral charge. That means when you put one proton with the neutron, it's still one because it doesn't cancel it out. It has no effect on it. It's just one. And last, it is added to the number of protons to determine an atom's mass. All that means is, remember on here, well, here, I'll do this. On here, we picked boron, which has an atomic number of 5, and that tells you how many protons and how many electrons, okay, there are. So we put 5. 1, 2, 3, 4, 5. With me? But this number down here, this 10.81, this is your atomic mass. So when I say is neutrons is added to the number of protons to determine atom's mass, that means however many neutrons are in here, that number plus that 5 equals 1081. But we're going to round to the nearest whole number. So what is 10.81 rounded to the nearest whole number? 11, right? Now, I know I have 5 protons in my nucleus. So how many neutrons do I need to add to make up that number 11? 6, right? So I'm going to draw 6 O's. With the little, you can do the line in and or out. It's up to you. But there you go. Now I have 5 protons equals my atomic number, and 6 neutrons, and 6 plus 5 equals 11. And don't forget about your electrons out here. And that is protons, neutrons, and electrons broken down in steps.